For more than 100 years, Schneider Electric has been an industry pioneer of market-leading solutions. As the engineering landscape rapidly changes, no one feels the impacts of the mounting challenges like consulting engineers. We understand these challenges. We face and solve them with you every day. Projects are becoming more complex, faster moving, and the connected world demands immediate answers while margins grow tighter. As an expert in your own right, we're set on making sure that you're equally matched in the manufacturing company you turn to, which is why we're launching Proficient for Consulting Engineers, a suite of services and tools that gives you unparalleled control from design to implementation, solidifying a real connection between highly qualified professionals. Proficient is built on a foundation of E2E, or expert to expert. Through innovative technology, responsiveness, and industry-leading BIM advancements, Proficient is tailored for you. All backed by market-proven Square D and Schneider Electric products with matchless service and support, we're delivering expertise that enables you to excel. You spoke, we listened. Proficient for Consulting Engineers. Expert to expert.
Good day to all. Welcome to Proficient for Consulting Engineer Expert Webinar Series. Today, our topic is Energy Codes and California Title 24. I am Wendell Leisinger, your moderator, Segment Manager for Consulting Engineers. I have an opportunity to focus on consulting engineering firms, their design processes, regulatory requirements, and the impact of disruptive technologies like BIM. Today's sponsor is Schneider Electric and the Schneider Electric brands. Please join our portal. Our portal provides you with continuing education modules, direct access to tools, building information models, latest in products and solutions, and also it has access to our experts on demand when questions arise. About this webinar, please note that you may type in your questions at any time in the Q&A box. I will be monitoring, and Drew and I will answer questions as available. Please note that you will be able to download the slides from this webinar in the Resources folder, which is the fourth button on the bottom from the left on your screen. There is a PDF for this particular webinar. Last, please note that you can get your certificate of attendance for this course today on our Consulting Engineer portal. Click on the Training tab at the top to select the course and generate a certificate. Please note that for people that are registered on the site, certificates will be available 1 hour after this course. For those that are newly registered today on the portal, your certificates will be available 48 hours after your registration. You will also be able to see this course again on demand through Schneider Electric Consulting Engineer portal. Our presenter today is Drew Reed, Offer Manager, Energy and Sustainability Services, Schneider Electric. Drew has had various roles spanning marketing, product management, engineering, and operations for energy management products and solutions. With that, I'll turn it over to Drew.
Thank you, Wendell. I'd like to welcome everybody to our webinar on energy codes. Energy codes affect virtually everything in a modern building design, from outside, the outside building envelope, to all of the systems on the inside. And so altogether, this is a very broad topic. Today, we're going to focus on one aspect of this, and that's how energy codes are beginning to affect the design of electrical distribution systems. And in particular, we're going to look at California's Title 24 code. Now, California has been traditionally on the forefront of code adoption, and California's approach to energy codes and the resulting building designs often have an influence on the other states. So today's agenda, just reviewing it briefly, first we're going to just have a little history lesson on energy codes, how they came into being, and how they evolved to the codes we have today. And in this context, it's important to understand how ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, has become influential in creating these standards on which the codes are based. And then from there, we're going to drill down to California's current Title 24 Energy Code and what it means for the design of electrical systems. And then at the end, we're going to wrap up with a look at 2016 and what energy code changes are expected in the future. Now, I think probably some of you in the audience may remember this. There was an energy crisis back in 1973. But before 1973, energy was abundant, gasoline was cheap, and everybody went about their lives without even thinking about energy. It was just there. And energy was so cheap back then, it was wasted. Homes and buildings were built with little insulation, and the efficiency of HVAC systems was low. This all changed in 1973 with the oil embargo, and overnight, the supply of energy became very limited, and it taught us a hard lesson on how energy is critical to the way of life we enjoy and our national security, and it's a resource that can't be wasted. So let's take a look at how energy codes have evolved. Now, as a result of this 1973 crisis, the U.S. government directed the National Bureau of Standards to develop criteria for efficient building design. And these design improvements focused mainly on the primary cause of waste at the time, the building envelope, and the HVAC systems. The National Bureau of Standards enlisted ASHRAE, who was the largest organization supporting the HVAC industry, to develop the first energy standard, which at the time was known as ASHRAE 90, and that was published in 1975. And that standard continued to evolve through the 80s, and of course it still continues to evolve today. But along the way in 1992, there was a law, the Energy Policy Act, and that elevated the ASHRAE standard to become the law of the land. And so it wasn't a voluntary standard anymore. It became a law in which the states are required to adopt energy codes that are at least as stringent as the ASHRAE standard. Whenever the ASHRAE standard is updated, the Department of Energy reviews it, and if they determine that the new standard will achieve greater efficiency, the states must begin the process to revise their codes. And from the point of that determination, states have 2 years to certify that they have reviewed their codes and have updated their codes to meet or exceed the current standard. And so right now, the current standard for state compliance is the 2010 version of the ASHRAE standard. Now, in 2014, of course, things keep continuing, and in 2014, the Department of Energy approved the 2013 ASHRAE standard, and that set off another round of state certifications, and the states must upgrade their standards by September of 2016. Now, this chart shows how the Energy Code mandate has had a positive effect. This shows the long-term effect that the standard has had on energy usage in commercial buildings. And the changes along the way, including the changes of the 2010 edition, the energy is projected to be about 1/2 of the 1990 level. Now, the Department of Energy has an ultimate goal of achieving zero net energy in commercial buildings by 2013. So these standards and the requirements are going to continue along this path until we get there. So let's look closer at the ASHRAE 90.1 standard. The 2010 standard includes a section on electrical power distribution. These mandatory provisions in the standard directly reduce energy consumption. There's a couple of things here to look at. There's voltage drop, the requirements for feeder and branch circuit conductor sizes. They have to be of a certain size to reduce the amount of loss to less than a certain percentage. They also introduced automatic receptacle control to eliminate the power consumption of plug-in devices by turning off receptacles during typically unoccupied times. But then there was one other proposed requirement that did not make it into the 2010 version of the ASHRAE standard because it did not directly save energy. This proposed requirement was for energy monitoring. And so you might wonder, why energy monitoring? How does energy monitoring actually save energy? And, it doesn't directly save energy, but it plays an important part in saving energy. And just, for example, if someone were to receive a utility bill after the end of the month, it doesn't really give them any insight to how the energy was consumed. But if they had some discrete real-time information, a facility manager would know where to go look for problems or improvements. And that information would guide actions to save energy. And so there's many studies that support or that document energy savings from 5 to 10% as a result of energy monitoring. And so in 2012, ASHRAE published an addendum to the standard that says energy monitoring shall be installed. And in addition to the total building monitoring, they also put in there, as you can see on the right-hand side, some groups that they monitor by particular load types. So HVAC, lighting, receptacles. Having those categories monitored separately provides more insight to consumption. But an energy standard like ASHRAE 90.1 is just a book on the shelf until a governing body adopts it into law through either their legislative or regulatory process. And so it comes to the individual states to adopt energy codes. And some states will alternately adopt something called the International Energy Conservation Code, or the IECC, as the basis for their state's energy code. The IECC is very similar to the ASHRAE standard and also recognizes compliance with the ASHRAE standard as compliance with the IECC. States are free to make changes or write their own standards. The only real requirement is that a state standard saves at least the same amount of energy as ASHRAE 90.1. I'm going to pause here for a second. Wendell, have we had any questions come in?
There are no questions at this particular time, Drew.
Okay. Well, in that case, I'm going to go ahead and begin a look at California's code. The state energy code in California is Part 6 of Title 24, and this was first enacted in 1978. Title 24 is typically revised on a 3-year cycle, which follows the publication of the new ASHRAE standard. The current Title 24 2013 standard is based on the ASHRAE 2010 standard and partially on the 2012 addendum. On average, new requirements from each cycle reduce energy consumption by 15%, but California's 2013 standard exceeds the average by a wide margin, and the energy savings are expected to be 33%. So like all building codes, these are minimum requirements. Actual energy savings can be higher by exceeding the minimums. Now, as an open public record, you can download Title 24 for free from the state website, and that link is at the bottom of the slide. Now, besides the standard, California publishes additional guides to help in the understanding of Title 24. In addition to a set of FAQs, there's also a document called the Compliance Manual, and that provides detailed explanation for each topic in the Energy Code. Now, the code language itself is very brief, and although the Compliance Manual is not a legal document like the code itself, it provides helpful insights to proper application of the code. And they include application examples to help the reader understand the intent of the code. So it's a very important companion document to them. There's some other additional resources for information and training. These resources are not only found on the web, but California offers telephone and email support. And those links and that information is on the slide. Now, the focus of today's webinar, as I mentioned before, is electrical distribution systems, and that's found inside Section 130 of the code. This section contains altogether requirements for lighting systems and equipment. Now, Section 130 applies to non-residential buildings and also the public portions of high-rise residential buildings, hotels, and motels. Now, to ensure compliance, California provides forms for building inspectors, and there's an example at the bottom of this slide. Just shows the top of one form. This form is actually 7 pages long, and it can be found at that link. Now, the forms themselves follow the requirements of each code section, pretty much paragraph by paragraph. And so for electrical power distribution, the building inspector will verify that the code has been met by comparing the actual building construction against the checklist contained in the form. Now let's look at Section 130.5. That's the electrical power distribution system section. And in this section, there's 6 topics. A and B, service metering and disaggregation of electrical circuits, relate back to that 2012 ASHRAE metering addendum that I mentioned. C and D, which are voltage drop and circuit controls for 120-volt receptacles, those relate back to the mandatory requirements of the 2010 ASHRAE standard regarding voltage drop and automatic receptacle control. And then E and F relate to systems and connectivity. So let's take a close look at topics A and B in Section 130.5. These topics are based on the measurement of energy consumption idea from the 2012 ASHRAE addendum. The first topic, A, describes the requirements for service metering, which measures total consumption. The second topic, B, describes separate measurement of consumption for different types of loads. California has taken the idea from ASHRAE, and they've made some adjustments to that. Since measurement does not directly save energy, they stop short of requiring meters to be installed for each load type, but instead they mandated that the design have provisions to enable simple measurement for energy analysis. We're going to look at that requirement in more detail in just a moment. But first, let's look at Section 130.5a. This section requires energy monitoring or energy metering to be installed for each electrical service. And the statement they have here is each electrical service shall have permanently installed user-accessible metering of total energy use. So the meter must be accessible to the user, and it also must comply with some features that are described in Table 130.5a. The utility meter may be sufficient if it indicates instantaneous demand and has a user-resettable register to display kilowatt-hour consumption. If not, a separate meter will need to be installed. Now, it might be more accurate to call this topic source metering, since metering is required for any source of power. So, for example, if a renewable power source such as photovoltaics are installed, those would be metered separately. One other thing to consider is that the point of service is not necessarily the same as the utility feed. This paragraph here is from the 2013 Compliance Manual, and it clarifies the intent by saying that the service to every building or structure must be metered so that building energy use can be monitored. So if the utility meter feeds multiple buildings, then a meter is required for each building. This meter does not need to have revenue grade accuracy, since its purpose is to monitor energy use. It's not used for billing. So this is Table 130.5A that I mentioned before, and it provides details on the type of meter required. These requirements vary based on the size of the electrical service. Even the smallest services require a meter with the instantaneous kilowatt demand and kilowatt hour that's resettable by the user. So that's the minimum requirement, and most utility meters don't meet that requirement. Now, as the services become larger, then they need a meter that records historical peak demand, and then the largest services additionally require kilowatt hour per rate period. Although we can envision a panel-type power meter to satisfy these requirements, keep in mind that a circuit breaker trip unit with metering functionality and a local display can do the job for all but the largest services. So that's section 130.5A. I'm going to pause again to see if any questions have come in. Wendell, do we have any questions?
Yes, there are a number of questions coming in. Danny asked, have any POCOs, that's publicly owned companies, offered utility meters that meet the requirements of 135 or 130.5A without the need of adding an owner meter?
I do not know specifically of any utility meters that meet the requirement, although it doesn't mean that there aren't any. It is possible that there are some meters like that.
Yes, and we'll advise if we find out more. Brian asked, did you say zero energy in buildings by 2013, or was it 2030?
It's not that shocking. It's 2030. That is the goal. The construction practices at that time are intended to be zero net energy in 2030.
Thank you. And one last question. IECC 2020 is the National Electric Code and Energy? What does IECC stand for?
That's the International Energy Code.
Thank you. That's all for now.
Okay. Let's take a look at section, or this 130.5B. This section is more interesting. This is California's approach to the measurement of the different types of loads, and it captures the intent of that ASHRAE standard, but California stops short of requiring that meters be permanently installed. They refer to this as disaggregated measurement, and they say that the system shall be designed to permit the disaggregated measurement of electrical load energy. And this topic can be a little confusing, so it's important to read it very carefully. Now, this is Table 130.5B, minimum requirements for separation of electrical load. And this is an important table in the section, and it describes a progressive set of requirements based on the size of the service. Smaller services do not have any requirements at all to separate their loads other than for renewable power and electric vehicles. The first level of separation requires separating lighting, HVAC, water pumps, plug loads, transit systems such as elevators and escalators, and large loads greater than 25 kVA. Then as you read across the chart, the requirements become even more granular as the service size increases. The load separation described in the table is accomplished by single separate feeders to each load type. This allows a permanent or a portable meter to measure energy use at the point of the feeder. So for example, a feeder will supply all lighting loads, which allows a meter to measure the energy use associated with lighting just by putting it on that feeder. Now, since a meter does not have to be permanently installed, there are no accuracy requirements for the meter, no requirement for any information to be displayed, no mention of accessibility to the measurement point. So it doesn't detail that here in the code. Now, in some cases, the table sets an upper limit on the load supplied by each feeder. And also, a feeder may not supply loads of more than one type unless the service is rated at 50 kVA or less. Now, since all of this can be confusing, let's take a closer look at the code paragraph. This first part, shall be designed to permit, indicates that meters do not need to be permanently installed, only that the design shall permit separate measurement. The second part, disaggregated measurement of electrical load energy uses, refers to the load separation requirements per Table 130.5b. So far it sounds simple, but then it goes on to say additive and subtractive methods may be used. Now that statement has caused some confusion, and I've heard discussion of it, and it's been said that if mathematics can be used to derive energy measurements for different types of loads, then it could be argued that any electrical distribution system design meets the code. Just take a lot of measurements and have a calculator handy. But that's not what the code intended. So the key to understanding lies in the three methods specifically described here that are associated with that statement. Okay, the first method that's mentioned here, it's straightforward since it describes the separate distribution equipment. If the design has separate switchboards, motor control centers, panel boards, to which are just connected the required loads, then the design meets the code. So for example, measuring the energy use of a lighting panel board will measure the energy use for that load type only. Now this is a diagram that comes out of the compliance manual, and it illustrates that first method. Each feeder here serves a breaker panel, a load center, load or load group with its own disconnect and subdistribution. So as you look at that illustration, you can see the different feeders. And as a reminder, services less than 50 kVA do not require the disaggregated wiring. So this is only necessary when services are larger than that. Now let's look at the second method. It may not be practical to supply all loads of a particular type from one piece of equipment, so the code also allows for sub-panels. And this can also be important when loads are greater than 25 kVA. And if you look carefully, this method 2 is interlocked with method 1. It says, second statement there, it says that sub-panels of the above separate equipment can only have connections of the same load or group of loads. Now there's a couple different interpretations of that wording. One interpretation is that the loads of the sub-panel need to be of the same type as the panel to which it is connected. Now the other interpretation is that the loads of the sub-panel could be of a different type. And of course, those would be very different designs depending on how that wording is interpreted. So again, let's look at the compliance manual to see what the authors may have intended. Okay, this illustration shows a sub-panel having the same type of loads as the panel to which it is connected. In this case, all of the loads are lighting loads. Now don't forget the first method says to which are connected only the required loads or group of loads. And so based on that, that interpretation would not allow a sub-panel to have loads of a different type. Now, another thing that has caused some confusion is the proper application of a split bus panel. And this is another diagram that appears in the compliance manual. And this illustration shows a combined feeder supplying different load groups in the panel. The diagram shows measurement points that allow the separate measurement of load energy. And split bus panels, however, have been an area of difficulty for inspectors. Now, it's probably worth mentioning that the National Electrical Code does not contain any reference to split bus panel boards. They consider it to be a panel board, and all of the panel board requirements apply. Now, for Title 24, the split bus panel board appears in the compliance manual, not in the code itself. The compliance manual shows the internal construction of the split bus panel board that meets the intent of the code, which is what we had in the previous slide. And each section is a sub-panel. Now, more importantly, though, each sub-panel needs to be capable of independent measurement, as was shown on that previous illustration. Now, this diagram here, first of all, I want to mention that this diagram does not appear in the compliance manual. It's a modification of the previous diagram, but it's to illustrate that there are some split bus panel boards that may be manufactured like this. Now, in this arrangement, the sub-panels are connected in series, and the arrangement doesn't quite meet that intent of the code because the top sub-panel is not capable of independent measurement, and it also has connection to loads of a different type. And so the only way to make this work would be to use the subtraction as mentioned in 130.5b, but this approach would still be in conflict with the other code language. And so the acceptance of this approach has been mixed. Now, it's up to the individual inspector to whether to accept this or not. There may be some inspectors that understand the code and the intent of the code. They may reject it. Now, the final method of the three methods says that branch circuits, taps, or disconnects rated at 60 amps or higher do not need to be combined for measurement at a single point. Now, if you recall Table 130.5b, in which the separation of loads becomes more granular with lighting loads divided by floors, etc., this is where you can take measurement and use the addition to get the aggregate total for a load type. Now, the code allows a couple of exceptions for the separation of loads. Okay, one is related to metering and the other is related to existing conditions. Let's talk about the existing conditions. So if renovations are made to a building and the existing equipment remains in place and unaltered, there's no need to go redesign and change the distribution system to comply with separate wiring requirements of the code. It does allow minor changes, such as adding branch circuit, changing load connections. All of those changes can be made without triggering this. The other exception to the separated wiring is when a metering system is permanently installed. The metering system can read various points in the distribution system, and it can combine them to provide these disaggregated measurements by the load type. It does it automatically through the system and software, and because of that, there's no need to segregate the loads by type through wiring. Now, there's an additional cost for a metering system in this case. However, the design flexibility may reduce the amount of distribution equipment needed for the project, or it could also reduce physical space, and so some trade-offs may make it worthwhile to put in the metering system versus the separated wiring. So note that I need to point out here that the metering system must be installed. This is not a provision for future installation because that would just allow just anything to go. So if to take advantage of this exception, the metering system must be installed. Now this is an example of a panel board metering system, and this system measures each branch circuit individually. And so using a panel like this, there'd be no restrictions on the type of loads connected to the panel board because the individual readings would be combined by the system software. One significant advantage to having a metering system installed, the building owner would actually get data on energy usage, while the separation approach stops short of actually providing any data at all. So, so this is something that is inherent.
Drew, maybe I can interrupt.
Yes, Wayne.
Tim has a question. Will your Schneider Electric product MVP HAR sufficiently conform to the requirements of disaggregation?
Yeah, in fact, that is the picture I'm showing here. That is an MVP panel, and so that would that in conjunction with the other aspects of the system that would comply.
Thank you.
Any other questions?
That's all for now.
Okay. What I'm going to go on to next, and of course, this is really a very quick tour through Section 130.5. But let's look ahead to 2016 and the changes that are coming that will affect this section. I mentioned before in 2013, there was the addendum in 2012 for the ASHRAE standard. And then when ASHRAE published their 2013 standard, they incorporated that addendum. So now that is no longer just the addendum. Now that's part of the ASHRAE standard. And so the publication of the ASHRAE standard triggered that review by the Department of Energy that I mentioned before. And so the Department of Energy, they reviewed the ASHRAE standard. They determined that the new standard will achieve greater efficiency than the previous standard, and so they made that formal declaration. And so that formal declaration set the deadline for the states to review and update their energy codes. So what's been happening now in California is California has been moving through the Title 24 revision cycle and the changes for 2016, and those changes are nearly complete. Now, when they go through that process, they put out a draft, and then they have public comments and review, and then they put out another draft, and they have more review. And so just recently, they published the 15-day language, which is the last draft before the final publication. And of course, they call it 15-day language because it opens a 15-day review period, and then during that period, they get comments from just from the public. And so now that period is closed, and they have they're in the process now of creating that final version of the new standard. So that's not been they've not quite finalized it yet, but based on the 15-day language, we get some insight as to what those changes are going to be. And they are still not requiring metering to be installed. But they have made changes to that Section 130.5b to reduce the ambiguity of the current language. And this next slide here that shows kind of shows how dramatic the changes are. They've pretty much crossed out almost all of the wording in that section because there's a lot of words there. And they're trying to reduce the potential misinterpretation and ensure that the intent of the standard is met. So they've removed that word disaggregation entirely, and they only refer now to separation. And they removed the language around additive and subtractive methods. And so that section has now been replaced with one simple statement. And all it says is electrical power distribution systems shall be designed so that measurement devices can monitor the electrical energy usage of load types according to Table 130.5b. And that's the table that describes the separation. And that table itself is mostly unchanged. So it just shows how the different load types must be separated in the design. And so if you're interested in all of this, you can go to the Title 24 website and find the 15-day language of the code. And as I mentioned, the committee is making the final edits per that public input received during the comment period. And the final version should be available soon, if not already. It was not available the last time I checked, but their schedule shows that it should be, published by now. So, but anyway, that's what we can look forward to in the next code cycle. A little bit more clarity around these requirements. So, before we go back to more questions here, just recap some of the things we've talked about today. These building energy codes, they're intended to save money, increase reliability, and ensure a sustainable future. So, these are all very good goals. They're not meant to cause aggravation. So keep that in mind. And they're going to continue to drive these codes because they want to get to that end goal of the net zero energy consumption. Now, the compliance with the codes, of course, that was affecting the design of our buildings and, of course, the design of electrical power distribution systems, and can probably anticipate more changes as we go forward. Now, most of these code requirements, they do actively reduce the amount of energy consumed, but the measurement of energy is important because it provides information to guide the reductions in energy use. So I'm going to open it back up again for questions. Do we have a few more questions, Wendell?
Yes, we do, Drew. Stephen asked, is the IECC, which is the International Energy Conservation Code, headed towards these requirements? If yes, do you have any idea when it might begin?
I think they're headed towards the same requirements. The IECC tends to follow, to some extent, the ASHRAE standard. Now, remember, the ASHRAE standard is the basis of the law in the United States. So they do tend to parallel each other, although they may not be exactly in step. And because they have their own time scales, but the states also they are free to base the state energy codes on ASHRAE or the IECC, or they can make up totally their own standards. The end requirement is they have to show that their standards or their codes save as much energy as the ASHRAE standard would save.
Thank you. Dave has a question. Does the 130.5b deal with commercial, industrial, or governmental facilities?
The code says non-residential. So it would apply to all of those facilities in California.
Great, thanks. Danny asks, in a campus environment, is the meter required per 130.5a required at each building or the service? The verbiage in standards does not use the word building.
The intent of it is for each building, and they clarify that in the compliance manual and they say it very clearly that the intent of the code is for each building because it's to help manage building energy use. And if it's a service to the campus, it would not be as effective as knowing what the usage is by each building.
Thank you. Brian asks, has Title 24 spread beyond California yet?
Well, let me say it this way. Title 24 is a California code. So Title 24 does not, itself extend beyond California's borders. However, other states, they draw their standard or their codes from a similar source, which would be the ASHRAE standard. And so, in general, the other states tend to mirror California to some extent, with maybe some variation. Now, one thing about California is California as a state is very serious about energy reduction, and they're very progressive, and so they are on the forefront of this. And so, a lot of things that are done in California do end up being copied in other state codes.
Thank you. Another question, maybe you've answered this, but for clarity, are there exceptions for industrial type facilities like water, wastewater?
I specifically can't say whether there's exemptions or not. However, my reading of the code, I have not seen that exemption.
Thank you. Brian asked, does the 2030 net energy goal mean that all buildings will require solar, wind, etc., or will credits be traded, bought, sold to be compliant?
That's an interesting question. The goal is zero net energy, and so there could be some mechanisms in place as long as the net is zero. So it's hard to say, but and of course that would affect buildings being constructed in that period. So we'll still have a lot of the building stock will be not zero net energy, but it's still the goal we're trying to progress towards as time goes on.
Thank you. Eric asks, do photovoltaic meters need to be grouped together in the same location? Can they be in different locations?
Trying to think now, there is a section 110, I think it's 110.10 of the same of Title 24 on solar-ready buildings, and I'm trying to remember what that says, but there's something in the table. I'm trying to remember what it says in that table 130.5b, but it's I think it may be by group. I'd have to go back and look at the standard again to be sure. But it's definitely the renewables need to be measured, and I think if they're different types of renewables, they would be measured separately. But I'd have to look at the code to be 100% certain of that.
Okay, thank you, Drew. Another question, how does automatic receptacle control work, and how much can it reduce consumption?
That's another interesting one. First of all, the automatic receptacle control, just to provide a little more detail on that, it's 50% of the receptacle, so it doesn't mean every receptacle is controlled. But I think in California, it's you have to have a controlled receptacle within 6 feet of an uncontrolled receptacle, and so that allows the occupant of the building to plug in devices as appropriate. So, for example, the computer monitor might be appropriate to have it controlled, but maybe a piece of, or let's say your computer's docking station, which charges the battery, that may not be something you'd want to control because you want to have your battery charged. And so you have controlled receptacles and uncontrolled receptacles, and then you also have the user in the building making the decision on what is appropriate. And so now these receptacles themselves are often controlled in conjunction with lighting. And so if you can imagine automatic lighting, turning off lights, that signal could also be used to turn off the receptacles at the same time, because those lights are turned off by either time schedule or occupancy signal or something like that. And so the code allows the receptacles to be controlled differently, just through different signals as desired. But then at nighttime or unoccupied times, those loads that would just be sitting there on standby would be turned off, saving 100% of the energy. And altogether, it doesn't seem like a lot, but I think I've read some things that have said that plug loads are something like 18% of the energy usage of a building. And so turning some things off that aren't necessary when people are not around, it could save a percentage of that 18%. So that comes from the ASHRAE standard, and that got implemented in California, and other states are implementing that. And so we can probably expect to see more of that as time goes on. So there's kind of a long answer to that, but that is a part of 130, 130.5 that I didn't really cover in any detail.
Thank you. A follow-up question to that. People are clever, right? Why wouldn't people just plug into the end-switch receptacle with the plug strips?
And they could. I think there's probably, human nature being what it is, I'm sure some people would do that. But I think at the same time, if people do that, they don't get any payback from that equipment that was installed to switch the receptacles. And so, and it's mandatory that equipment be installed. And so, building owners would probably be, it's in their best interest to try to enforce the people in that building to do the right thing and use those as appropriate. But I'm sure there will be some people that will try to circumvent that.
Again, another similar question from Kevin. Does ASHRAE and Title 24 require control 50% of the receptacles in the entire building, or just the offices?
There's some exemptions. I'll say it's the entire building, but they exempt certain types of receptacles, like if it's for a clock, it's high on the wall. I think if it's for data type areas where you may have networking equipment, and they are listed in that section. But there are some exemptions to that. But in general, it's the entire building. And just to be more specific, I'll just say it's not just offices. It applies to the open areas as well, in addition to private offices.
Thank you. Mark has a question. Do you have panels coming out that will incorporate both lighting and receptacle controls?
Schneider Electric does have a panel that has controllable circuit breakers that can be used to control either lighting or receptacles. And so, and Schneider Electric's not the only company that makes a product like that. So, so there are some electrical panels that could be applied as part of a scheme to do this.
Checking for more questions. Another question from Brian. Who enforces Title 24? And what are the penalties?
If you recall, there was I had something in one slide. I briefly touched on the inspectors that will inspect for energy compliance, and California has actually put more effort into compliance, lately, and they've got the set of forms, and all of those forms are out there at their website. So it's taken the mystery out of it. That's the form that the inspector will follow when they're checking to make sure everything has been complied with. And so now, as far as penalties go, I think they could keep a building from getting a certificate of occupancy, like other if other other building codes are not in compliance, they would not issue a certificate of occupancy, and I think that's the same penalty for energy codes.
One last question. Will 2016 codes, are they aggressive enough to meet 2030 net zero targets?
Well, I would say they're probably headed in that direction, but it's going to take a lot of code cycles between now and then to get there. So, and I don't know what the measure is for for this next round, but I had a statistic there in the presentation that on average every code cycle reduces by 15%, and so 15% is a good chunk, and so over many code cycles between now and 2030, I think we'll get probably get there if they keep down that path.
Good. Thank you, Drew. There are some more questions, but the time is running out, and we will be answering all questions that have been sent in to us. Thank you, Drew, for your insight. Please note that you can register on the Proficient portal, or please register on the Proficient portal, and you can click on the training link to access the course, Energy Codes and California Title 24. Click on the certificate icon and you can receive a certificate of attendance for your continuing education credit requirements. Please note if you have registered previously, these certificates will be available an hour after the presentation. For new registering individuals, it'll be 48 hours after you register. If you have any questions or other information that is required for certificate-related questions, there is a link to our portal support team. Please note also that on the bottom of your screen, the fourth button is an exit survey. We would appreciate a lot if you would answer the short exit survey before you leave this particular On24 platform. Also, at the bottom, the sixth button from the left is the resource folder that you can download a PDF of this particular presentation. With that, this ends the Proficient for Consulting Engineers Expert Webinar Series on Energy Codes and California Title 24. Thank you for attending. Have a great day.